again. Welcome to my classroom again, Mother. So before we get into today's activity and the topic, I just want to ask you a couple questions about what you know about the seasons. So thinking about summer and winter, what do you think are the big differences that you notice about those two seasons between summer and winter?
Well, the temperatures are the biggest difference. I mean,
Okay.
summer's hot, winter's cold,
Exactly.
usually, and it's darker in the winter and lighter, longer. The days are longer in the summer.
Exactly. Yeah, we get longer daylight hours in the summer. So today we're going to look at why we have those seasons. And I have this model of Earth. And as you can see, there is a skewer through it, and the skewer represents the poles of Earth. So this one pointing this way, that is the North Pole, and then the one with the circle is the South Pole. And as it rotates, it actually is pointed towards the North Star. So is that straight up and down? Do you notice?
No, that's at a slant.
So the Earth is actually rotates on a tilt, and we're going to see how that gives us our seasons. Are you ready?
I'm ready.
All right, thank you. So I've created a model of our orbital path of Earth around the sun. And what do you notice about this path? Is it completely circle?
No, it doesn't appear to be.
No. Is the sun directly in the center of the path?
No.
And it's not in real life either. So the sun is a little bit off kilter. And I also wanted to point out on your Earth model, do you see that line? That is a representation of the equator. So on the North Pole, on this side, is the northern hemisphere. And then what's this going to be then?
The southern hemisphere.
Your favorite season is fall. So we're going to start at the 23rd of September. And I want you to point the North Pole, the North Star. And as you rotate the Earth, observe where the sunlight hits on the hemispheres. Is there one hemisphere that gets maybe more sunlight than the other?
But it's kind of equally, kind of like right here.
On the 23rd of September, or around the 23rd of September, is something called the fall equinox. Now, what does that word kind of sound like? Equinox.
Something's equal.
Yeah, that means as far as the sunlight then, you think that word means equal.
So they would be getting equal sunlight on the northern and the southern hemispheres.
Very good, yeah.
Yeah.
So if there's 24 hours in a day, how many hours of sunlight does each hemisphere get?
I guess 12.
Very good, yeah. Very good. We're here at the 21st of December. It is called a solstice. So here in the northern hemisphere, what kind of solstice do you think they would be experiencing?
Oh, I guess they're having summer solstice.
You think in the northern, they're going to have summer?
Oh, no. They're going to have winter because it's colder.
Exactly. Why is it colder?
Because the sun is further away.
Is it because the sun is...
Or they're further... They're tilted
exactly
away at a different angle.
There it is, tilted at a different angle. And we'll go over that closeness in a minute. So let's go ahead, actually. We've gone past winter solstice, and now we're going to the 3rd of January. So our days are actually getting longer. I know that this model makes it look like only the southern hemisphere is getting sun, but we're still getting sun. But what do you notice as far as the shape of this and the sun being not in the center? Are we the closest or the furthest away from the sun at this point?
It feels really close.
We are at the closest point to the sun in our orbital path here. But remember, what season are we in here?
This is winter for us.
So we're in our coldest season. Why are we not experiencing the hotness of the sun if we're that close?
We're not the sun is not directly on us. It's directly on the bottom of the Earth.
Exactly. So when it comes to seasons, it's that direct light that creates the heat, not so much the closeness. Any questions?
Mm-mm.
So now we're moving on to what season after winter?
Spring.
Spring. We're at the 21st of March. And again, what do you notice that is similar here that we may have seen?
It's on its side, so there's equal light on both the southern and the northern hemispheres.
Exactly. What was that word that we used before? Starts with an E.
Oh, I forgot.
That's okay. It rhymes with equal. That's okay. It's
Equinox.
It's the equinox. Very good. What season are we in?
Spring.
Spring. So that would be the spring equinox. And are both hemispheres, is one hemisphere getting more light than the other?
I don't think so. I think it's pretty equal.
Exactly. All right.
Around
And now,
this part, anyway.
my favorite season. What do we move on to?
Ooh, summer.
Summer. So this is the 21st of June. And the North Pole is pointed towards the North Star. So what season is the Northern Hemisphere in?
Summer.
And by looking at the light, are we getting longer daylight hours or shorter?
I would think longer.
Exactly. At the 21st of June, the sun in the Northern Hemisphere is at its highest point. And do you remember that S word that we used around winter, then the 21st?
The solstice.
Exactly. So what season are we in?
We're in summer.
So this will be the summer solstice for the Northern Hemisphere. And now, just after, a little bit after the summer solstice, we come to the 3rd of July. And what do you notice about our location in the orbital path? Are we far? Or
We're pretty far away.
We
Since
are.
It's the furthest away.
So again, seeing how far we are, yet we are in our hottest months, what does this tell you that gives us the hot days?
Just the constant sunlight.
A lot of sunlight hours. And what about that angle of the sun? Is it more direct or indirect for us?
I guess it's direct.
Exactly, it's more direct. Thank you again, Mom, but I'd like to wrap things up to see how much you've learned from this activity. Thinking about if you were an animal in the wild and you don't have a nifty calendar to tell you that the winter's coming, how do you think you would be able to tell that there's about to be a big change in the seasons?
Well, I mean, the temperatures are going to change, and with the angle of the earth and the light, the less light in the winter and the shorter days and then the cooler days.
Very good. Yeah. So yeah, you're exactly right. It's the change in the light that gives a lot of animals and even plants the cues that they need to start bunkering up for the winter. So
just like when there's an eclipse.
Ooh, that is a whole different animal, but it's really fun, and we can look into that on our own time. But
okay.
Thank you.